Unit 1 Review, Problem 1. Healthy females have a mean red blood cell count of 4.8 million cells per microliter of whole blood, with a standard deviation of 0.3 million cells per microliter, and a mean white blood cell count of 7,250 cells per microliter of whole blood, with a standard deviation of 1,375 cells per microliter. A female patient is given a blood test. Her red blood cell count, or RBC, was found to be 4.3 million cells per microliter, while her white blood cell count, or WBC, was found to be 6,100 cells per microliter. Part A. Relatively speaking, does this patient have a lower red blood cell count or white blood cell count? Here the key is relatively speaking. That is, we're not trying to compare the actual red blood cell count to a white blood cell count. The relatively speaking is having us compare the red blood cell count of this patient for what red blood cell counts are typically for all the other patients, and what a white blood cell count is for this patient compared to all the other white blood cell counts for the other patients. The way we can compare two different things and their position, that is, whether it's higher or lower, in a relative context, is the standard score. The standard score can be used to compare the relative position of different data values. In this case, the blood cell count of this patient with the lower standard score will be considered lower, relatively speaking, for this patient. To calculate the standard score, we need to take the data value in question, that is the one we're trying to find the position of, and subtract the mean for all the other data values, and divide that difference by the standard deviation of all the other data values. This is represented by the formula for Z, the standard score, is equal to X sub I, the particular data value we're finding the position of, subtract mu sub X, the population mean for all the other data values, divided by sigma sub X, the standard deviation for all the population values. So in this problem, to determine whether this patient has a lower red blood cell count or white blood cell count, we need to calculate two different standard scores. One for the red blood cell count, and the second one for the white blood cell count. Starting with the standard score for this patient's red blood cell count. This patient's red blood cell count was found to be 4.3 million cells per microliter. Then we subtract the mean red blood cell count for all healthy females, which was 4.8 million cells per microliter. And then we divide this difference by the standard deviation of 0.3 million cells per microliter. We can calculate this result on the calculator by grouping the numerator first, using a left parenthesis, and then taking the data value of 4.3, subtract the mean of 4.8, close parenthesis, divide by the standard deviation of 0.3, enter. Here we get the result of negative 1.66666. Standard scores are typically rounded off to the nearest hundredth, or 2 places after the decimal. So to determine rounding, we look at the next decimal place over, or the thousandths, or the third place after the decimal. Here we see it's a 6. Any time that decimal place is 5 or higher, then we round the next decimal place over up. So here, the standard score for this patient's red blood cell count rounds to negative 1.67. Now to calculate the standard score for this patient's white blood cell count, we start by taking her white blood cell count, which is found to be 6,100 cells per microliter. And then we subtract the mean white blood cell count for all female patients, 7,250 cells per microliter. And then we divide by the standard deviation for the population of white blood cells, which is 1,375 cells per microliter. Now we can calculate the standard score for the white blood cell count on a calculator by grouping the numerator and going left parenthesis, 6,100, subtract 7,250, close parenthesis, divide by 1,375, enter. So this patient's white blood cell count standard score is negative 0.8363636. Again, rounding to the customary hundredth or 2 places after the decimal. We look at the next place over, there's a 6, which is the over 5. So the 3 rounds up to a 4, and we get a negative 0.84 for the white blood cell count standard score. Now to answer the question, which one is lower, we can compare these two values on a standard score scale. The red blood cell count standard score of negative 1.67 is negative, which is below average. So this patient does have a relatively low red blood cell count, but it's not past negative 2, so it's not an unusually low blood cell count. In comparison, this patient's white blood cell count was negative 0.84, which is also negative or below average, but it's not quite as low as the patient's red blood cell count. So because the standard score of the negative 1.67 is definitely less than the standard score of negative 0.84, this patient's red blood cell count can be considered, relatively speaking, to be lower than her white blood cell count. So now we're ready to answer the question. Relatively speaking, this patient had a lower red blood cell count because her red blood cell count standard score of negative 1.67 was less than her white blood cell count standard score of negative 0.84. Here we were able to correctly answer the question, but it's also necessary to show your work and show your reasoning and method of solving the problem. So here we showed the work of our calculation of the standard scores, but it's also important to support our answer by clearly showing that the standard score of negative 1.67 was less than the standard score of negative 0.84. And because of that, the answer was red blood cell count was lower. So be sure to answer the question correctly, show all your work, and support your answer by showing the reasoning and method by which you solve the problem. Now we can go to part B. Classify as to the type of data and determine the level of measurement for the particular data item, blood cell type, that is, whether it's a red or a white blood cell. Here we're being asked to do two things. 1, classify the data by type, and 2, classify the data by its level of measurement. Type of data can be classified 2 ways. Data is either qualitative or categorical, or quantitative, which is numerical. And quantitative, numerical data can be further classified as either being discrete or continuous. Discrete data values result when there's gaps between data. That is, it's not possible to get data values between particular data values. Whereas continuous data values means it is possible to get betweens. That is, you can get any value along this continuous interval. Level of measurements, there are 4, starting with the lowest, nominal. The next is ordinal, then interval, and the highest is ratio. So we'll do these one at a time, starting with the type of data. And it's very important to know specifically what particular data item we're classifying, because this problem has lots of different data values. It has the red blood cell count, it has white blood cell counts, it has means and standard deviations, it has whether the patient is healthy or not, or whether the patient is female or not. But specifically, we need to focus on this data item, the blood cell type. That is, when we're looking at the blood cell, the data that's being collected is it a red blood cell or white blood cell that we're looking at? Since the blood cell type is either red or white, is categorical, we classify this type of data as qualitative. So the blood cell type, whether it's red or white, is considered to be qualitative data. Now, for the level of measurement. The blood cell type is either red or white. Red and white are the names of these blood cells. And that's all we have here. So the level of measurement for the blood cell type, whether it's red or white, is the nominal level of measurement. So now we are ready to answer the question. The blood cell type, red or white, is qualitative data that reaches the nominal level of measurement because red or white is categorical and only represents the name of the type of blood cell. Here again, we answered the question, but we also provided our reasoning for providing these answers.